Hello students, we are going to start with the next theorem, that is theorem 10.2 of standard 10 circles. To start with this particular theorem, we have done already first theorem. Now this second theorem is very important and very simple. As a quick recap, the first theorem deals with the tangent is always perpendicular to the radius. Let's see theorem 10.2. The length of the tangents drawn from an external point to a circle are equal. As you all know that here in the exam it will come, prove that the length of tangent segments drawn from an external point to a circle. So when any theorem is there, we have to write given, to prove, construction and the proof. So it has mass. So first let us verify or visualize the diagram. So here there is a circle. So to start with, let's draw a circle. So there is a circle and there is a point which is outside the circle. Length of the tangents drawn from an external point to a circle. So there is a circle. So we are taking a point outside the circle. Let the circle be with center O and let the point be taken as P. Now we have to draw the tangents from the point P to the circle. So you all know tangent definition. Tangent is a line which touch the circle. Tangent is a line which touch the circle. So here we are drawing a line which touch the circle, which is passing from the point P to the circle. So here is my tangent that is drawn to the circle, the first tangent. Now let's draw the second tangent, because you all know that from a point outside the circle, two tangents are drawn. From a point outside the circle, there are two tangents drawn. So again from the point P, two tangents are drawn. Let's take a little closer, and here we can find that here the line touch the circle. So I have drawn two tangents are drawn from the point external point. Let it meet the circle at the point A and B. So here we have to prove that, students, that length of the tangents that is drawn from an external point to a circle are equal. So from this point P, the tangent segments are PA and PB. PA and PB, and we need to prove that PA and PB are equal. Correct? So first let's write what is given. So given is a circle with center O, a circle with center O. Here we can say PA and PB are the tangent segments, drawn from the external point P. So are the tangent segments drawn from an external point P to the circle, from an external point P to the circle. And we need to prove that PA and PB are equal. So to prove PA equal to PB. Now to prove this, we are going to use we require something. Now here there is nothing, either here it's not a quadrilateral or a triangle. So here the simple construction we will do is, we'll join OA, OB and OP. So let's write the construction. So construction is, students, join OA, OB and OP. Now from this you can see very clearly we have got two beautiful triangles, and if we prove these two triangles are congruent, we can say PA and PB are equal. Why congruence? Why not similar? Because we all know that if two triangles are similar, if we prove, then the sides are proportion. Now here we have to prove they are equal. So we need to prove that these two triangles are congruent. Now what is OA relation with AP? OA is a radius. What is AP? Tangent. And we all know what is the relation of radius and tangent. It is perpendicular. Correct. Again OB is a radius and PB is a tangent. So radius is perpendicular. So we have got two right angle triangles where this OP is acting as a hypotenuse for both the triangles, and this is common. And we know that OA and OB are also equal. So by RHS, it's a right angle triangle. OA and OB are equal, one side, and the hypotenuse equal. Therefore, these two triangles are congruent by RHS. Therefore, PA and PB are equal. So here we start with the proof. So here we can say that first that OA is perpendicular to AP. We can also say OB is also perpendicular to BP. And here we can write the reason, tangent perpendicular to radius. Now, once we have said that is 90 degree, so here we can write that angle. Here we can write consider triangle. Here we are considering triangle OAP and triangle OBP. So here when we consider the triangle, let's write the reason here. The third point, we will say that angle OAP is equals to angle OBP. As we all know that is 90 degree, or you can write from 1. Then we also know that OA and OB are equal, that is radii of the same circle. Similarly, you can find out the common side is OP. So here we can write hypotenuse OP equals to hypotenuse OP, and the reason is common side. Therefore, triangle we have. Therefore, we can say therefore triangle OAP is congruent to triangle OBP, that is by RHS. And therefore, we can say PA is equals to PQ. Sorry, PA equals to PB, that is CPCT. Now here we proved, therefore, that if there is a circle and tangents are drawn from the external point of the circle, then the tangent segments are equal. Now from this same proof, students, now the proof is complete. We can derive many other things which can be used for the application. Like for example, with the same diagram, can I say that these two angles are equal? Let me just shade it so that you understand here. Like for example, APO is also equals to BPO CPCT. Similarly, I can say AOP is also equal to BOP. Why? Here CPCT. So from this we can get that these two angles are equal, these two angles are also equal. So here I can say angle AOP equals to angle BOP. So here I'll just write the note. So from this we also get the very important fact, students. Right? Here I can say the proof is over, but I'm just continuing for that so that you understand here that angle AOP, or I'll just write here so that it's more very clear. Okay. So I write here so that the diagram is more visible. So here I just continue that angle AOP is equals to angle BOP. This is CPCT. Now whenever you use, why I am stressing on this, it means whenever I have to solve the sums, when you have a tangent segments drawn from an external point, I can say that we know this fact that these two angles are equal. So this can be framed as tangents drawn from an external point, tangents drawn from an external point, subtend equal angles at the center, subtend equal angles at the center. So you can use this fact that if you're drawing tangents from an external point, they subtend equal angles at the center. So here you can find very beautifully that angle AOP and BOP, and you can use it for solving the sums. Similarly, when I say that angle APO is equals to angle APO and BPO are equal, this is also CPCT for the triangle. So here we can see tangents drawn from an external point, tangents drawn from an external point. So if you're drawing are equally inclined. So the tangents are equally inclined. Now this equally inclined, these two angles are equal. They are equally inclined to this line segment. Now how you are getting this line segment? From the center and to that point. So tangents drawn from an external point are equally inclined to the line segment, joining the center and that point. Similarly, we can have one more. So I said that from this we understood these two angles are equal, these two angles. We can also see that this is a special type of quadrilateral AOBP. Do you find this a quadrilateral? Yes. And we find that opposite angles are supplementary. As we know, angle A is 90 degree, angle B is 90 degree. So angle A plus angle B is 180. So what can you say about angle O and angle P? So we come to know that angle O plus angle P will also be equal to 180. As we can say simply that this AOBP is cyclic quadrilateral, we can say. It is cyclic. So, or we can use angle sum property of a quadrilateral. If this both are 180, so obviously angle O plus angle P is also, the sum will be equal to 180. So here this the extension, that means from this particular theorem we understand many facts that we come to know that by the same thing, that these two angles are equal. So if these two angles are equal, we say tangents drawn from an external point are equally inclined to the line segment joining the center and that point. Similarly, if these two angles at the center they are equal, so they subtend equal angles at the center, and these two angles are supplementary. So I hope you have understood this, a very simple proof, very important proof, and the applications where you can use by solving the sums. So thank you students. Thank you for watching this video. Thank